We're going to be thinking about linear transformations.
Here we see two teachers teaching different topics in further mathematics. They are both exploring strategies to develop understanding by building on prior knowledge and making connections. In this first case, with complex numbers.
I want you to think about this quadratic case of y equals x squared minus 6x plus 5. I just want you to try and write down everything that you know about it.
The students use mini whiteboards to collect their thoughts, initially as individuals.
Right, so let's just take some ideas then of what we've got about this quadratic. So,
I completed the square.
you complete the square. So when you complete the square, what did you get?
You get x minus 3 all squared.
Yep.
Minus 4.
Minus 4.
We worked out the gradient function.
Oh, so you got the gradient function as well. So that is?
dy by dx equals 2x minus 6.
Okay, so here we have the graph of x squared minus 6x plus
Using
5.
a dynamic software package, the teacher helps students relate the algebraic expressions of the quadratic to its graph, identifying the features that students had recalled previously. For instance, its turning point and its real roots.
So what we're going to do, is going to watch what happens here with our roots as I translate this graph up and down, so vertically. So if I move it once, we'll get x equals 3 plus or minus root 3. I move it again, x equals 3 plus or minus root 2. We were keeping an eye on the roots and we tried to spot a few patterns with that. What we have is a solution of 3, in this case plus 1, and 3 minus 1, which corresponds to our solutions up here. What's going to happen when I move it up here? What's going to be next in this square root? Tyler?
Minus 1.
Root minus 1. Let's have a look. It's 3 plus or minus root minus 1. And eventually we realised that if we moved above the x-axis, we'd sort of generate imaginary roots. So this diagram, it doesn't represent our complex roots, but over here we can use an Argand diagram to show these complex roots. And we could sort of see those really nicely of how they moved apart from one another on the Argand diagram. If we keep on moving, the best thing about it was that the students could really see exactly what was happening with the roots and linking sort of the graph to an Argand diagram. So thinking about that, what I want you to try and do is come up with a quadratic with a complex root of 5 plus 2i.
They cancel, don't they? Yeah, it's minus 10.
That cancels.
That's plus 10, and that cancels.
In the Argand diagram, it shows they've always got to be complex conjugates.
Which then if you,
So then
if you do it, it's just x.
Just substitute it into this, and it should give you a quadratic.
5 plus 2i.
So what I want you to do is just look at this and the vertex and just try and see if you can see a link between our roots and the vertex itself. So I'm just going to move this up and down. Yeah, Lucy.
As you move the vertex up or down,
Yeah.
the y coordinate of the vertex equals the negative number in the square root of the roots.
Okay. So say I wanted roots, or one of the roots to be 5 plus 2i. So where do I have to move my quadratic vertex to get that as one of the roots? Tyler?
5, 4, yeah.
We're going to be thinking about linear transformations.
Here, a slightly different approach, in this case to relate matrix multiplication to transformations. In the lesson, the students are to work in groups with card matching activities, making connections to consolidate and extend their understanding. Before this, the teacher begins by asking students to think about what they already know.
Thinking back to GCSE, what sort of transformations did we do?
Like moved it by the vector 1, 2, which moved it like
Okay.
1 on the x-axis and 2
Okay.
on the y-axis.
And what do we call that sort of transformation?
Translation.
Yeah, translation, when we moved or slid stuff. Sam?
Enlargement.
Yeah, we did enlargements. Got in my head where I think the students should be at the start of a topic and what they should know before, but until I actually do that checking, I don't know. The other reason I think it's really important is it just builds confidence that even before we get into any inverted commas new maths, they're actually reminding themselves, yeah, actually I know quite a bit about this already. What we're going to do is we're going to take a step back, and we're going to think about what matrices you would have for those simple transformations we did at GCSE.
So I'm guessing.
I'll start there and go that way.
So,
No, that's an enlargement.
oh yeah, that one. Oh wait, no, that's just a stretch. With a 1 there and a 0 there, because then you get 2 there.
Yeah.
And then it needs to go to -1.
Nope, wait.
Again, think about that. That's
So
a 2 by 2.
Then you want
so that
a
needs
0
to be
there
Zero to
a
minus
2 by
and
1.
-1
So
there.
we want that one.
Yep. So it's the one with the. Taken the point that it was originally,
Yeah.
and the matrices that we don't know what it's been times by, we've called A, B, C, D.
Okay.
And then that's got to equal the point that it's now turned into.
Was a pair of students who decided to do it in reverse and say, right, here's a transformation, this point goes to there, what must the matrix have been? They were coming at it from a completely different angle. That was really encouraging.
1 minus 2,
Yeah.
and then we're making equations from each point.
Okay, so 2A add B has to be 1.
Yeah, and then
2C
2C
add
plus
D.
D has to be -2, and
Right.
then we're going to take the points 0, 0, and the other 2, and put them into equations. We want to leave
The y
X
coordinate,
where it is.
don't we?
Now for the students to explore these relationships further in their groups. They have access to the software.
What are you hoping that is? That's
Stretch and scale factor of 2 in the direction of the y-axis.
absolutely. So at the start, when we were talking about the different sorts of transformations you came across at GCSE, the very first example someone gave me was Ben, and he said translation. And I just wonder, having done that activity, whether anyone's got any ideas as to why we can't do translation with matrix multiplication.
Well, the origin doesn't get affected by any point because it's 0, 0. So if you multiply anything by 0, it's just going to remain 0.